Hi, welcome to the Calculus 3 lecture series. And in this video today, we're going to start a new unit. And this new unit, we call this the partial derivatives. So basically, the whole unit, we're going to focus on the derivative part. And instead of the one variable, we're going to focus on the 2 or 3 or multi-variables here. So the lecture number 1 for this unit is we're going to talk about the function of several variables here. Okay, so for the first ones here, we just go to basically take a look. When we start to define the functions here, we talk about the domain, range, and the graph, those things. And so that's what we're going to start off as the very basic when we go to the 2 or 3 variables. Okay, so let me go to our worksheets here. Okay, so before we start, okay, so let's let's take a look here. And so in here, we always work in R2, and then now in here we work in R3. So let's first take a look in R2. What did we learn and how we apply to the R3 here? Okay, so let's take a look. So in the R2, right? So we have a function. So we say y is equal to f of x, right? So the graph of these functions here is in the R2 space, R2 coordinates here. So it's x and y. So the graph of this function is a curve, right? Or we can say it's a line, but it's, the curve is a general term for line also. So it's a curve here, right? Okay. So now, so now in R3 here, so we have 3 variables. Then we say the z is equal to a function of x, y here, all right? So when the z is equal to the function of x, y, then the graph of this ones here, right? So the graph here is y and z. So instead of a curve, and the graph will be some type of the surface, right? Depends on what type of the function we have. So the graphs here, it will be what? It's a surface, right? So this will be is a surface. Okay, so that's the first differences in here. So then the value of x is here, right? So in R2, the domain we defined is the value of the x's here, right? So the value of the x satisfy the graphs here, right? So we say it's the value of the x, the whatever this function is defined, then the range is here is what? Is the value of y here, right? So like in here, so the same things here. So the domains here will be so right now, I have 2 variables here, right? I have x and the y here, right? So the domain, it should be the value of what? X, y, right? So all the pairs, right? So the values of x, y, who satisfy this, these functions here. Then the range is here, is right. So it's the value of what is the z values, right? So will be the surface values here. Okay, so like in R2, we say the domains here were typical if there's no restrictions. So the domain for the x here, typical we say is in the, belong to the real numbers. But then we say, okay, be careful. We have a few things we need to check, right? So if the functions, right? So if a function is a fractions, right? So if you have some like gx over hx, so if a function is a fraction, then the domain need to exclude, right? So the domain need to exclude whatever the value of x make the domain, make the denominator equal to 0. That's the first, when you say, okay, so we start with the real number, then whatever, the denominator equal to 0, we need to exclude. Then the next things here, we say, hey, you know, if you have f of x is some type of the function, like the root function, like if this is like nth roots, right? So if it's even roots, then we need to exclude what? We need to exclude the value of the gx is less than 0, right? That means that whatever the domain will be, all the value of x is greater than or equal to 0. Of course, then we have like the natural log function. So for example, you know, if f of x is equal to some natural log function like gx, right? Then we say the gx here cannot be 0, right? So cannot be. So we need to exclude all the x here is less, you know, we need to exclude all the x here, then the which make the gx less than or equal to 0, right? So those are the things we say, hey, you know, we need to be careful, you know, for the R2. So the same thing is for the R3s here, right? So instead of consider just variable x, you need to consider the variable x and the y's here. All right, so let's take a look at some examples here. So in here, that's what it said. Okay, let us set, okay, let's see the keyword. Let D be a subset of R2 of functions of two variables, right? Then we have, you know, so for each pair in D, then f of x, y, you know, have a unique value. So this is, we say, is the domain of the f of x. And the same things here, the range of the y is a set of all these f of x values. So it's the z values here, right? So now, you know, so in the R3s, right, your domain will become what? The domain will become area, right? So like in here, if you back here, right? So the like in here we said in the R2, the domains, right? So what is the domain? Domain will be some type of the interval, right? So if you say here is the domain, so will be this interval. Then in the R3s here, we extend it because I have both x and y. So the domain, if we say this is the domains, right? So the domains here we say what? Will be some type of the area, right? So it will be, you know, I shouldn't say area. So I should say it's like will be some type of the regions, right? So it's some type of the region, right? So some type of the region satisfy both x and y. Okay, so now also the other things we need to pay attention, we say the graph of the two variable is the surface, all right? Okay, so now let's take a look at the first problems here. So let's say, hey, what is the domain of f of x, y? So this is just like we say, oh, okay, the x and y will start out with the all real number, but this is the fractions, right? So fractions here, so we say the only way they have no defined is 5x minus 10y equal to 0, right? That means if your denominator equal to 0, this is not defined, right? So this is x equal to 2y or y equal to the 1/2 of x here. So that means, okay, so the domains here, so that means what is the domains here? We say the domains here, right? So it's x and y, okay? So the domains here, they both the x and y is in the R2s, right? Except y cannot be equal to the 1/2 of x, right? So if you graph it, so this will be the domains, right? So this is x and y. And then you graph y equal to the 1/2 of x. So x equal to 0 is 0, x equal to 1, 2, so it's 1. Okay, so that means the domains here. So this is the line y equal to 1/2 of x. So the domains here will just be all this area, right? All this area except I cannot include these dotted lines here, okay? Okay, so let's take a look at the next ones here. We say find, okay, I'm sorry, okay, so here, the next one is say, find the domain and the range of this one. So the domains here, right? So we said the domains here, this is a fraction again. So the only thing is x squared plus y squared equal to 0. This is what we need to exclude, right? So x and y can be any number except this ones here, all right? So now when x squared plus y squared equal to 0, what I have here, that means I know the x has to be equal to 0 and the y has to be equal to 0. All right, so that's why I know for these ones here, I know the domains here will be equal to all the xy. So will be all the xy in the R2 except what? Except y, xy cannot be what? 0, 0, right? And so that is what the domain will looks like. Let's say the 0, 0 is here, right? So then the domains here will be everything here, everything in this R2 planes here, except this 0, 0s here. Now also let's take a look at the ranges here. So for the ranges here, right? So the range, I know x squared plus y squared is always greater than 0s, right? So because x squared plus y squared is always greater than 0, so I know the whole distance here has to be greater than 0. So the range is going to be what? From the 0 to infinities here, right? So like you say, why is it getting to infinity? Because when the x getting smaller and the y getting smaller, you have a smaller value, then you flipped it, it will become pretty big, right? Okay, so now this is pretty simple. It's just whatever you learn in R2 is the same thing you apply. Let's take a look here. So f of xy is defined by these tables here. So what is the domain, right? So remember, this is 2, right? So the domains here will be what? Will be the pair, right? So it's 1, 4, 1, 5, 1, 6, 2, 4, 2, 5, and the 2, 6. And this is 3, 4, 3, 5, and the 3, 6, right? So that is our domain. So domain is x, y here, right? And now, what is the range? Range is the value of what is z's, right? So that means those are the value of the z's here. So now I can say, okay, the range is here, right? So it will be those value. So it will be start with this -10, -3, -1, and then 2, 3, 4, 7, 8, right? 2, 3, 4, 7, 8 here, right? So this is our ranges here. So now the next thing is like here, they say, hey, what is the f of 2, 5? Okay, 2, 5 is these numbers, right? So f of the 2, 5, I know this is -10. So it's pretty simple. What is the 4, 3? Okay, so the 4, 3 is here. That means x equal to 4, y equal to 3. Hey, this number, the x equal to 4, y equal to 3. 4 and 3 is not exist, right? It's not in the domain. So I know the f of the 4, 3 does not exist, correct? Does not exist because of what? Because this pair 4, 3 is not in domain, right? Okay, so now the number 4 is here. Say, hey, let's try to describe the graph. So remember, this is the z, f of x, y is z, right? So it's z equal to the x squared here. So because of missing y, so So has to be along the y-axis, right? So parallel to the y-axis. So if you take a look, z is equal to the x squared. So what this graph, if you just look at the z and the x-axis and z-axis, this is a parabola, right? Right, so this is a parabola. Okay, so because you're missing a value, so you become what? You know, if all the line in this graph are parallel to certain line, then we call it the cylinders, correct? So this one we call it, this is parabolic cylinder. This is a parabolic cylinder because I'm missing y, so I say along with the y-axis here. Okay, so those are pretty straight, you know, it's a pretty easy here, right? Okay, so now the next things here, the next few problems, just like you to get familiar with like the software, which can help us, you know, try to graph here. So the first things here, I said, okay, so we try to graph this function, z equal to the e to the x squared and the minus y squared. So what is this function looks like? So in here, of course, there are many different softwares available. So in here, you can use Calcplot 3D or the Wolfram Alpha software. And so if you have a more advanced software, you can use it. But here, we don't need too advanced. We just want to take a look at what is this graph looks like, right? Okay, so now let me show you what is the Calcplot 3D going to looks like. Okay, so this is the Calcplot 3D. So basically, you just type in your browser and say Calcplot 3D here, right? Then here is the function you input. So you say e to the power negative x squared minus y squared. And then here, you can switch the how long the x-axis, y-axis. So as you can see, this is our the graph is look like a bell, right? Look like a bell, like the upside down bell. And one of the things I like about the Calcplot 3D, you can turning this around, right? So you can see, whoa, what this looks like from the different angles here. All right. So you will see that this graph here, which is kind of like up, is kind of like the bell, right? The bell, like sitting there, right? So this is kind of like the bell. Okay, so that's it. Okay, so then the next things here. Okay, let's go back to my worksheets here. All right. So the next things here. This is okay. The very important terminology because we're going to use it in the later sections here. So we need to take a look at the level curve, okay? So the level curve, right? So what is the level curve? The level curve is kind of like the, it's kind of like the, like we said, if you have it in the space, right? So if you have something like this bell curve, like the bell, we just graph this one is like in the spaces here. So the level curve is kind of like the cross sections, right? So it's kind of like the cross sections here. So you kind of cross sections, right? So you kind of cut it, then you see after that what is the trace would be look like, okay? And so like some people will call this is like the contour plot, right? So it's a contour. Okay, so it's kind of like the contour plot. So basically, you imagine, like you have a knife, you cut you cut this graph, and your knife is parallel to the XY planes here. So you will get what we call is the level curve, or it's a contour plot. Or like if you like the outdoor things, and sometimes you look those map, like the contour map, right? So if you are trying to climbing a mountain, Okay, so this is what we call is a contour map. So what is this contour map? The contour map really is just basically it's a level curve. So you treat the mountains, right? It's a 3D surface. Then you use a big knife to cut it, right? So that's why, because you use a big knife to cut it, so all the points on a certain level here, they have to be the same, right? So you see, okay, so this is the 500, so this is 500 feet, maybe this is 800 feet, and this is like 300 feet, and this is 200 feet, right? That what is we call it is the, is the level curves here, okay? So let me, okay, so let's make sure here we know what we talk about. Okay, so we said level curve is a subset of the domain of F. The level curve not a part of the graph. The graph is the solid, like so it's a 3D surfaces here, right? So all the point on level curve have the same F value, just like we talk about, like if you are in here, this is the contour plot. So that means when you walk in this ones here, you're all walking in the 800, feet level. And if you're walking in here, okay, so that means all you're walking is the 300 feet levels here, right? So the two different level curves. So if the K1 is equal to K2, then you get a two different level curve, and they will not intersect, right? It's because you kind of, you kind of cutting it parallel to the, the XY planes here. Okay, so now in here, they said, okay, sketch the curve f of xy equal to the x minus y square. Then, let's try to do what is the level curve means, right? Okay, so that means when x equal to 0, when k equal to 0, that means the height is equal to 0 is equal to the x minus y square here, right? So this is x minus y square. Then you know this is x equal to what? Y square. So what do you have here? You have a parabola, right? X equal to y square, right? Okay, so now if you set the, the k equal to 2, you have x minus y square. So you have x equal to the y square plus 2, right? So what's that mean? That means still it's a parabola, and then, in here you just add 2, so you will have a, like a graph like this. So this is what we call the level curves here, right? So let's take a look. How can I use the plot 3D tools to help us to plot the level curves here, all right? Okay, so this is the one we just did, right? Z is equal to the x minus y square. Okay, so take a look here. So if you put this function, so this is, right? So this is what the, the function looks like. Okay, so think about here. Okay, so now I'm going to find the level curves here. So the level curves here basically is just like you have, remember you have like a knife, right? So looks like you have a knife and then you're cutting it, right? So similar like here, right? So you have a knife, you cut it, right? You cut it, so this knife parallel to the XY plane, and then can you imagine, can you kind of visualize it? So you will get a parabola, right? So like if you cut here, you cut here, then the curves here will looks like a parabola here, all right? Okay, so now, let's take a look what is the level curve mean. So for the level curve, you hit this button here. Look here, like the level curve here, you hit this button. Okay, then you want to set, right? So you set from this example, let's say, hey, for k is equal to 0, so you set the k equal to -2. Then the next one is 2, you say, hey, 2. every time I step 2, how many I want, right? So you have a negative 2, 0, 2, 4, 6. Then you can change the color of those in, and you say, hey, created a plot. See here? That is what is your level curve looks like, right? So if you have the software, that will be pretty easy to help you to do that, right? Okay, so now let's go back to our worksheets here. So that's how do you plot the level curve. Of course, you can use hands to plot it, right? So you can just plug the number, or you can use the software to help you. Okay, so now, they said, what is the level curve for the f of xy equal to the xy's here? And then we said solve it first, algebraically, and then verify it by using the software. Okay, so level curve, so we know this is xy is equal to the value of k. Oh, so I recognize this. So what is this type of the function xy equal to the xy equal to the k, see here. So that means y equal to the k to the what? X. So do we recognize this type of function? Yes, this is a reciprocal, right? So this is a reciprocal function. So typical, we know the reciprocal functions is going to like this, or, we can have like this, right? Depends if x is positive or negative. So that's why I know, the level curve here, for this surfaces here is going to be a reciprocal function. So it's go here or go there, right? Let's take a look at how the software tell us here. Oh, right. So here, okay. So now let's go to my next curves here, right? Okay. So this one's here, right? So that's why, I define z is equal to xy. See here. Let's see okay. So the z is equal to the xy. So now you want to see the level. Yeah, this is what the z graph looks like, right? So it's kind of pretty cool, right? So now you want to see the level curves here. So basically what you do here is just like we said before, it seems like you have a big knife and you kind of cutting this, right? You're cutting this and make this one is parallel to the xy, right? So that is how do you get the level curves here. Okay, so now let's see, take a look here, right? So that's why you see the level curve. Let's plot the curves here. See, that's why when the x is, you have a negative and a positive, that's why some of it go here, some of it go here, right? That's what is the level curves here, right? So that's pretty cool, right? All right, so now let's go back to the, so let's go back to our PowerPoint here. Okay, so now in here, number 8 here, they said, hey, in here, z equal to the f of xy have a following set of the level curve. So this is the level curves here. So what is the function going to look like? Okay, so we said, okay, so we say, okay, the line, so these are the lines here, right? So this is k equal to 0. This is k equal to -1. So, okay, so in here, this is 1. So I know this, the linear functions, linear equations for those curves here will be what? So y is equal to x minus k, right? So when k equal to 0, when k equal to 0 is this graph, right? So is this goes through the here. So when the k, when k equal to 1, so you have y equal to the x minus 1s, right? So you will have where? So this is the 1, x minus 1s, right? So this is the, so this is how the level curve. So like this is the level curve. Then I know I can change these ones here. K is equal to x minus y's, right? So we said the level curve is where you set a what? where you set this is z value into the constant, correct? So now what is my function here? So I know my z function of f of xy is what? Is x minus y, correct? All right, so that's it. Okay, so let's take a look. Let's try to use the Calc3 plot to see if we'll be able to reproduce that. All right, so let's go to next tab here. Okay, so the next tab, the first thing here, you know, this is what we graph x minus y, right? That's what we just derived. So if you like, you can kind of, you know, turn around, see this, see here? That's what is this graph showing you, right? Z equal to the x minus 1 is the surfaces here. Now let's take a look to see whether the level curve happened like we suspected. Did we derive this function correctly or not? Okay, so let's level curve. So we say we start with -1, then I step 0.2, then to see whether you have that or not. All right, so this is the, okay, so let's take a look here. Now in here, we say create the plot. You see here, that's what we have here. So if you say, okay, -1, I don't want to step with 0.2, I step 1. Let's only do like 6 level curves here, right? Create the plot. Right, see here, that's what is exactly what the problem give us, right? So it's pretty cool, right? So you can see what is the level curve and what is the functions like. Okay, so so let's go back to our worksheets. What is the next problems here? Okay, so the next problems here, they said the graph of z equal to the 2xy, and we know this one is the hyperbolic paraboloid, right? And now let's draw the level curve. So first one's here, we draw from the 0.25, so increase 0.25. Then the next one, let's draw, you know, we're dropping -2.5 here, right? Okay, so now let's take a look here. Okay, so let's go to the our Calc3D, right? So this is my next one here, right? So it's 2xy. So it's pretty cool, right? So you see, this is what is the graph looks like, right? So this is what the graph, this is a paraboloid. And when you cut it, it will become hyperbolic. That's what this is called a hyperbolic paraboloid, right? Okay, so now let's take a look at the level curves here. So the first one, they want to increase, start with 0.05, and then they want to increase like 0.05. So let's take a look at this one here. So this is, let's see the created plot. You see here, so the level curve will be look like this. All right. Cool. Okay, so now in here also like they want us okay, so to start with -2.5, right? So we said we start with -2.5 and -2.5. Then let's see what do we have. Yeah, so we switch the curve to there, right? So it's pretty cool right here. So it will be very easy to help to see what is the level curve is, right? So remember the level curve is kind of like you just do a cross section, right? Imagine you have a big flat knife, you cut, you know, then your knife is parallel to the XY plane. You cut this, whatever the surface you have there. Okay, now let's go back to our worksheets here so we know what it looks like. Okay, so now we extend this, right? So we extend this to the R4 right now. So this is R4. So this is W equal, you know what this is, x squared plus 4y plus 9z squared. We know this one, so these functions here is in the R4, right? Unfortunately, I cannot visualize what the R4 is, right? And but it's the same idea. So like right now, let's say I want to find the level surfaces here. So every time you see a level surface, that means you set this W equal to 1 and 4. So if I set these ones here, so this is 1 is equal to, so this is one of the level curve, right? So because this is in R4, so instead of say the level curve, so what do we say? Level surfaces here, right? So that's what in here they say level curve, because in R3, when you do the cross section, you drop to the R2. So in the R4, when you do the cross section, you drop to the R3 here, right? So now this one's here is k equal to 1. So you will have x squared plus 4y squared plus 9z squared. All right. So you know immediately this is what? You know, if you from our previous unit, last videos, we say, hey, you know, these are R3, this is ellipse, right? So this is ellipse. So the same way, if the level curve is 4, so you have x squared plus 4y squared plus 9z squared. This is going to give you ellipse. It's not ellipse, ellipsoid, right? Ellipsoid. So it's a 3D. So we call it ellipsoid here. Okay, so that's the based on the formula, and so we say this is ellipsoid. So how can I use, you know, the plot tool to see what it looks like? All right. So here, okay. So here, let me stop here sharing. Let's go to my here. Okay. So now let's go to this ones here, right? So this is the one. Okay. So this is the one, right? So we say 1 is equal to x squared plus 4y squared plus 9z squared. So if you take a look here, right? So you really cannot, you know, put the 4 values there. Right? So in here, if you take a look here, all the function you can choose, right? So it's z, x, y. So it's R3s, right? So now, but you know, you always plot the z is a function of x, y here. So for this type of the problems here, so like how do you use this to help you here? So you solve for z. So you say the 9z squared is equal to the 1 minus x squared minus 4y squared. Then the z squared is going to be, this is 9, right? So this is 1 minus x squared minus 4y squared. So the z is going to be plus or minus 3. Then this is square roots of the 1 minus x squared minus 4y squared. So that is why, okay, that is why in here, take a look here, you do 2 graphs here. So first one's here, you do the negative one, then the next one's here, you do positive one. So that's why it will generate an ellipsoid. All right. So the same way, you know, so if you take a look at the same way for the, when the level curve, level surface is 4, right? So it's in here, you do the same ways here. So what do you have here? So in here, you will have what? So in here, you will have like instead of the 1, you have a 4 here, right? So in here, that's why this one is, you say it's a 4, 4, 4, 4. So that is the ellipsoid it generated. And then this ellipsoid is the level surface for that R4 functions here. All right. Okay. And so that's it. And I think we know how to, what is the, you know, the what is the level curve and the level surface. So these ones here, we talk about the functions, right? So it's very similar like in R2. The things we add new, we never talk about in R2 is this level curve and the level surfaces here. okay? And also, we introduced some software tool you can use to help you to graph. Special, we are in the calculus 3, right? It's a multivariate. So with some software, if you can see what that solid looks like, that would be pretty handy here. Okay, that's it. That's what is this video about, and looking forward to talk to you in our next one. So we're going to follow the same kind of the path in the calculus 1. So the next one, we're going to talk about the limit and the continuities here. All right, that's it. And nice to talk to you. You have a good day. All right, bye.